So, hello everybody. My name is Darek Kominek. I'm with Matricon from Honeywell, and today we'll be talking about OPC UA Security. Now, that's a topic that's quite important, obviously, out in the world right now. And there's a lot of efforts that are going on around the world in order to create the types of connectivity, the secure type of connectivity that you need to support the modern connectivity systems. So when we talk about the industrial Internet of Things, or we're talking about Industry 4.0, those are all systems that connect a lot of different devices across a lot of different industries. And of course, one of the things you want to make sure is that they're secure. So if we were to look at some of the efforts that I just mentioned, so Industry 4.0, in the North American side, there's a lot of the IIC, the Industrial Internet Consortium. Even in China, they have the China 2025 initiatives with Internet Plus. All of these different initiatives are trying to define how you're going to share information, and a key aspect of that is how will you do so securely. So OPC UA plays a fundamental role in this because it was designed from ground up for security. Now that's a nice thing to say, and a lot of the standards will say the same thing. So what really sets it apart? Well, one of the key things is how well does it stand up to actual testing? That's usually a very fast way to determine things. So one of the things that happened with Industry 4.0 is that they looked at it and said, okay, if we're going to have a lot of different verticals, a lot of different systems getting connected, how are we going to ensure that they're able to communicate with each other, and also to be able to share the types of contextual information that they need to? So they did a lot of testing, and basically in the end of it, what they came up with was that OPC UA was the only standard that they found at the time that would have both the security capabilities and the scalability and the context that was required to actually express that information for the different systems to share data between each other without losing context. So once that came out and it was identified that, okay, so OPC UA not only provides this type of security from a standards point of view, so theoretically when you look at the standard, does it have any flaws, let's say, for the security, and it passed that, it got a check mark. The second, more telling, I guess, test was also to then go and have BSI hire basically third-party company that went through and tested it. So they took an implementation of an OPC UA server, and they actually said, okay, well, let's test it. So they threw a bunch of attacks at it to see how does it support the security. So what I'm going to do in this presentation is actually go through that and talk about how does OPC UA cover this. Now, as you know, OPC UA covers a lot of different verticals. We've talked about this before. So, of course, this is important, again, for all sorts of reasons, whether you're talking about power grids or you're talking about pharmaceutical applications or medical. OPC UA is being used throughout. So if we were to sort of summarize it, when we have OPC UA talking in a lot of different domains and a lot of different layers within the enterprise, you know, this is why the security has to be sort of ubiquitous, right from the shop floor, from your intelligent, let's say, controllers or sensors, all the way up to the communications into the cloud. Okay, so that having been said, let's take a look at the actual security of what we need to focus on. So first of all, when we talk about security, you know, that's sort of a catch-all term, but really the broader, I guess, concept is trustworthiness. And what that basically means is that you're bringing in various aspects of making sure that the data is secure and reliable in order to have the system run correctly and to maintain the confidentiality and such. So there's a number of concepts that we could talk about, right? So from safety, security, reliance, also reliability, resilience to attacks, and overall privacy. So I'm going to focus just on the security aspect. And this is actually quite important because especially for industrial systems, when you're mixing in the IT world, which comes typically from the corporate and the sort of the business networks, and the OT, which is the operations side, which is what you find on the shop floor, you're really trying to blend those systems together so that you have the reliability that they need on the OT side, but you have the security that's also typically the major focus on the IT side. Okay, so when we talk about data security, I want to make sure that we're talking apples to apples here. When you talk about data, you really have data at rest. You can take a look at data in a process as it's being used, and then you have data in motion, which basically means that you're transferring data from A to B. So each of these is important. So for example, if you're storing data in a historian or you have it somewhere in memory, of course there are ways that a system could be attacked to look into memory. So that's one aspect of security. Another one is that as an application is running, as it's using the data, how is that exposed? And then the third one is how you're transferring literally from A to B. So in this case, for OPC, OPC is primarily concerned about moving data from point A to point B. So the security we're focusing on is the data in motion, right? And this kind of makes sense because when we talk about security in depth, where you basically want all the systems to, or as you're building a system, you want to have various layers of security built in. How you protect the data as it's stored would be different than how you're going to protect the data as it's being transmitted. Okay, so let's talk about data in motion, which is where OPC UA lives. Okay, so if we look at it, those of you who might be familiar with OPC Classic, where basically the first version of OPC came from, that was the first generation, that primarily focused on the supervisory control level, and it was basically sitting on one, let's say, part where you have your supervisory control type applications in typically process control. Now, as we move on and we say, okay, well, OPC UA is going to provide connectivity from the shop floor right down from, let's say, the level 0 or level 1, going all the way up to the cloud, you're covering a lot more layers in the networking, and therefore you have to have a much more, let's say, robust method of sharing or of securing that information. Okay, so there's a few concepts that we talk about. So first of all, we talk about being a trusted, or how do you create a trusted information model? And there we have the abbreviation CIA, which stands for confidentiality, integrity, and availability. So those are the key factors to make sure that your data, you can rely on it. And then also when we talk about access control, we have the 3 A's of access control, which is authentication, authorization, and also the auditability or accountability, but basically making sure that you know what happened afterwards, who did what, right? So kind of leaving a trace. That's very important because a lot of times you're doing post-analysis or forensic analysis. So let's take a look at what each of these means for those of you who may not be familiar with some of the, let's say, just conversation about security. So first of all, confidentiality. What we're really saying there is that let's say that we've got a bunch of information, we need to transfer it, and we of course want it to get to the right person, the ones who are supposed to see the production details. This is quite relevant, obviously, for all types of manners. It could be financial information, it could be sensitive production information, which maybe uses a competitive advantage. So you want to make sure that the data that you're sending across is confidential. And that basically means that an interloper can't come in and also snoop on your data and to see it. Okay, so number one, that's how we ensure that we have confidentiality. Integrity basically just means that as data is being sent by the originator, that mid-flight, somebody doesn't come in, do kind of a man-in-the-middle attack, and basically change the values as they're going across. Obviously, that could have catastrophic events. You don't want that to happen in both directions, right? So whether it's commands being sent out or the values that are coming back, you definitely want to make sure that that doesn't happen. When we look at, for example, the attacks that were done on the centrifuges a while back, what happened is basically information that was coming back, it was actually going in both directions. So the information that was coming back to people was actually telling them that everything is okay, even though the centrifuge wasn't okay, and it was slowly being wrecked. So definitely if you can't protect your data going through, you're going to obviously be open to that type of attack. Availability, basically what you're doing is you're making sure that if you have a load of servers talking, and I mean sometimes this doesn't have to be a malicious attack. This could be a bunch of devices that are misconfigured and they're continually trying to reconnect and, for example, causing a lot of traffic to come through, and they're hitting your server, and therefore the server gets swamped with requests for connections, and it's not actually doing its job and sending the information to valid sources, right? So that type of thing can happen as well. So that's what we talk about when we talk about availability. Now, when we talk about the 3 A's, so when we're talking about the authorization, or the authentication, and then the authorization, and then the logging. When we talk about authentication, this is done on 2 levels. Number one, you have to make sure that the applications that you're dealing with can be trusted. How do I know that, even though I know who the user is, the application that they're using, how am I going to trust that entity? So one thing is to have application or software certificates, which would identify that the particular software that's being used is trusted and known. And as well, you then also have user authentication. So now it's basically saying, all right, so let's say that the software application is okay, but who is it that's actually trying to communicate with me? Who's the user? Right? Now in Windows, of course, you've got your logon. There are other ways that can be done, but basically you're identifying the user and saying they are only allowed to connect because they're the ones that are getting authenticated. And once they're authenticated, then you, of course, do authorization, which is the next step, which says, what are you allowed to do? So just because you're allowed to communicate, just like think of a building. Just because you have a pass and you're allowed to enter the building doesn't mean you should be able to open every door in that building, right? So that's kind of what authorization does. It says, what are you allowed to do once you're authenticated and you're actually in? Which is extremely important because if you just have a sort of IT perspective or outside perspective outside of the application, what that means is you kind of have an all or nothing type of security where you basically say, okay, you either cannot connect to this thing or you can connect to it, but you don't have that granularity to come in and say, okay, well, what are you allowed to do specifically within the application itself? So once you have this set up you have the authentication and the authorization, the next step is to say, well, can I keep track of what actually happened? Which is basically auditability, where basically you can come in and say, all right, if there were commands given every time that the client and server have an exchange of information between each other, you're actually going to identify what the request was from which client, and therefore that gets logged in. Now, an important part to this as well is that if you have multiple systems from different vendors coming in and providing this type of information, one thing that you want to do is to define what are some of the standard things that you should be capturing, so that when you look at your logs, you have a fairly consistent trail of who did what. Right? So which client, which server, which client requested things, what was the response from the server, who was it that was actually requesting that type of information. This is important because in OPC we have the concept of being able to use, for example, aggregating servers, which means that not only do you have a server, let's say at the device level, and yes, you could have an application that talks down and a user is using that information. You can also have another server that sits above it and you're aggregating from one server to the next as you're bringing more information together into, let's say, a more powerful system with larger processors and such, and then exposing that up to a bunch of users. So as you're bringing those together and you're percolating a command down, you have to have an ability to log, to trace, to say how did that request go from one server, for example, through a series of other servers to and eventually to a client. Okay, so that's thinking through that strategy is something that can't be an afterthought where vendors just invent their own way of what am I going to put into a log file. This is something that when a standard is secure, in order to catch that third A, the auditability, that's something that needs to be sort of pre-thought and designed into the standard, which OPC UA does. Okay, so basically that's how you identify it. Now, those are sort of the basics of how things are set up, or those are the key concepts that we deal with when we talk about security. Now, when we look at OPC UA, it actually structures how you build up the trust or the connectivity between a client and a server, or something that behaves as a client and a server. Okay, so basically you have your transport layer, which identifies how you move the information across the network. So you might be coming over binary data coming over TCP. You might have XML data coming over HTTPS. But basically, that's your transport layer. OPC UA is able to swap in and out different layers that sit underneath. For example, in the pub sub, we're looking to swap that out, and it's going to go over AMQP if you're publishing out. But basically, that's flexible. So you have your transport layer, which may or may not include security or encryption. For example, HTTPS does. But if it doesn't, you can still use the encryption that's built right into the specification, the support for it that's built in. Okay, so once you have your transport layer established, you basically then start up and you say, okay, now we're going to create a channel, and then within the channel we have multiple sessions, right? So at each level, and if we look at the diagram, we can see that we got the application authentication, integrity, confidentiality, all those things. So for example, confidentiality being encryption, all those are built into when you're setting up your channel. So once you have that channel secure, now you're basically creating the sessions, and that's where you're identifying, okay, so who is the user and what am I going to allow them to do, right? The authentication and authorization for the users. Okay, and then you can have multiple sessions within a secure channel. Okay, so that's sort of how it's structured, of how you build up the communications and where, at what levels, which parts of security come in. But as you can see, every level has a certain aspect of security built into it. Okay, so when we talk about communications, the encrypting of messages, of course, that just means that you're encrypting the data that actually comes through. So you literally, if you were to capture the stream that's going between point A and point B, you can't make heads or tails of it because all the content is encrypted, and therefore you're protecting the privacy of your data. Integrity means that you're still using part of the cryptographic technology, but basically you're using the certificates to sign, you're using the certificates to sign the information as it's being transmitted. So even though it may not be encrypted and you could see what it is, because there is a signature on it, a digital signature, what you're guaranteeing is that that information didn't get changed, and therefore the integrity of the data is guaranteed, which is also important if you're not necessarily encrypting, but you want to make sure nothing got changed. And then availability, this is an important one for, like I said, if you have malformed packets that are being connected, or basically some kind of, let's call it a denial of service type attack, where basically you've got a lot of connections being requested and a lot of data being passed, or requests being passed to the server. And if the server spends too much time trying to work with each of the packets to say, oh, is the encryption correct, is the key correct, etc., you're going to use up a lot of CPU power just to work through the requests, and that of course steals away time for the processor to actually do the work that it needs to talk to valid communications, or to do valid communications. So the way OPC UA is designed is to actually, as quickly as possible, basically ditch the packets that are not formed correctly, so it's not wasting processing time, and therefore it's more resilient. Okay, so when we look at that, we've got the authentication, we have of the applications, we have authentication also of users, and that's where we use either username and password, or we're using certificates. So basically you're using the tokens or X509 certificates, which is typical. That's what the people from the IT world are very used to that. That's a relatively new concept on the OT side, that using that in order to build the trust, but that's a well-proven technology, or it's the best, sort of best of breed that we have right now. Okay, so that's the authentication of users. We have the authorization of the servers themselves. Now that is specific. So what you're doing there is, when you implement an OPC server, you are given that information of who was, when you're authenticating the user, you identify who is that user. And now the question is, what are you going to allow that user to do inside? Now, depending on how well an OPC UA server is written, that may be all or nothing type control, or it might be very precise and tied down to basically allow you to determine whether you're allowed to do each individual function on each individual tag, or per user per tag type security. Okay, and that just depends on what's required and how the vendor implements the UA server. But the specification provides all the tools that are required for vendors to write very controlled, secure OPC UA servers. Okay, and then auditability, again, like I mentioned, that's built into the standard. So there are definitions of standard things and how you percolate that data if you have stacked communications, where you have a server communicating through another server or aggregating through it in order to go to the top. That's all defined within the specification as well. Okay, so some of the examples, sometimes it sounds a little theoretical. So if we were to look at some of the examples, things like message flooding, like I said, that acts like basically a denial of service type of attack. So again, very expeditious dealing with the packets that are coming in, or the requests. Eavesdropping, so of course we got encryption that's built in if you want to use it, because again, in OPC you have a choice. If your transport offers the security like HTTPS does, then you don't necessarily, again, want to encrypt the data actually at the payload level. But if the underlying transport doesn't encrypt the data, then basically when you were using OPC, you would encrypt it within as you're packaging the actual information, the payload. Okay, message spoofing, which is basically creating false messages. Again, that's by signing. So encryption or signing will obviously do that. Alteration and replay of packages. So that's an important one. You might have a valid packet captured and just resent again. But the thing is, each of the packets are actually numbered, so there are actually quite a few additional pieces of information that a server uses that when you put it together will define whether that's a valid packet or sequence or not. So you couldn't just capture a valid packet and then send it again. You know, if you send open the valve by 1 notch and you capture that and you say, I'm just going to send it 10 times, does that mean that, you know, it'll open 10 times because the packet just got resent? And the answer, of course, is no. Because every interaction between the client and the server, actually the packets are numbered and it starts to identify that, wait a second, this is out of sequence, etc. So there's a number of those that are built into it on top of, for example, the signing that's done. Okay, so it's quite resilient that way. Okay, malform messages, which is basically, again, just trying to send garbage at the server to confuse it or to cause, again, additional trying to process the data. So rather than trying to figure it out of maybe it's a corrupt packet or not, basically the server just gets rid of it and, again, tries to stay efficient. Okay, so this is a sampling of some of the original thinking that was put into the OPC UA spec, so that this is built right into the DNA of the specification itself, again, by design. Okay, now there are certain things that are, of course, out of scope. So the way you, for example, do user management. So we talk about authenticating users and authorizing. Well, someone has to decide what users are allowed or not allowed to do, or how you even divvy that up. Is it by role-based? Or how do you define that? So that, of course, isn't in the specification. There are other standards that identify the proper IT type behaviors that you would do to set up your overall process, but that is not used by, that's out of scope for the specification. Okay, as well, password policies, right? So how complex are the passwords that users are going to set up? That is, of course, something that sits more on the IT side and more on the education side and enforcement for how people are using these things, as opposed to what a standard for communications would identify. Okay, so things like data ownership, who owns the data, where should it be, organizational issues. Okay, so for example, how do people actually gain access to the systems? How do you train people? Obviously, those are not part of the specification. But there are other specifications that basically tie into this, right? So if we look at ISA 99, NERC CIP, there are various standards that and regulations or regulatory bodies that actually focus specifically on that. Once you have when you bring in the standards from the different other organizations, OPC UA dovetails with them. And that basically means that you have a fully functioning system, both for taking care of what the specification does and also how it integrates with the rest of the system to provide an overall defense in depth type environment. So that basically brings to conclusion the high-level description of what OPC UA does. And hopefully you see from this that, you know, whether you're talking about the broad IIoT, Industrial Internet of Things topic, or a little bit more focused on Industry 4.0, primarily, let's say, for the manufacturing, or even more specifically when you're talking about more on the shop floor, the M2M communications. At each of those levels, there might be slightly different requirements for, you know, the data rates or how things behave, or even the degree to which you're going to have a lot of clients connecting or basically just two controllers talking to each other. But regardless of the situation, OPC UA was designed to actually handle all of those scenarios. And that's why when you look in the marketplace, you will see that OPC UA is very quickly starting to be identified, just as Industry 4.0, the organization did, that OPC UA really hits that sweet spot, acting as the glue between those systems and providing the security that's needed to keep these systems going. If you want more information about this, you can, of course, go to the OPC Foundation website at opcfoundation.org, and there's, you know, a lot more there. And that's it. So thank you very much. I hope you found this informative, and till we talk again. Thanks.